Okay, so this is for the What Are Hydrates assignment. Now, for this assignment, you needed to go and answer some questions about hydrates, but then you also had to perform some calculations using the hydrate examples from the bottom of the page. We're going to take a look at how to do those calculations, just looking at one example. So you're going to really want to try and follow the process and then apply this process to the other examples from that assignment. So the two types of calculations that you had to make were for the percent composition, which, as you can see, when we're looking for the percent composition, we're getting the relative amount of elements that make up the compound. So as an example, the percent composition of glucose, right, is 40% carbon, 53% oxygen, 7% for hydrogen. Now, for the percent of water in a compound, right? Remember, hydrates are essentially compounds that have absorbed water from their environment. So what we want to do is we want to say, all right, well, how much of this substance is water? We started off with a substance. A lot of times they are salts, and these salts will absorb water. So really what we're trying to figure out is what percentage of this salt is water. Now again, if we look at the example for the Epsom salt here, we have the Epsom salt, MgSO4, plus 7 molecules of water. So the formula mass of everything there, including the water, is 246, but the mass of the water alone is 126. So we would be doing a little calculation of 126 divided by the whole entire thing, 246 times 100. Okay, so again, and that 126 is the mass of 7 water molecules, and I know that there are 7 water molecules because of the formula. All right, so let's take a look at an example. This right here would be a useful chart to copy, because essentially when you're doing percent composition, you're really kind of filling out this chart. You can pause the video here to copy the chart. We're going to be using it to kind of go through this first example, right? So the elements in the compound, right? Hopefully you remember how to recognize an element in the compound. We've got some magnesium, we've got sulfur, and we've got oxygen. Now I'm going to add hydrogen and oxygen down at the bottom of this list, but the hydrogen and oxygen that I'm adding here is in reference to the hydrogen and oxygen that makes up the water that's a part of this hydrate, okay? Since I'm going to be looking for that percentage separately later on, I'm going to separate the hydrogen and oxygen from the water here in my list, okay? Now in the second column, we try to figure out how many of each atom is present. And again, we just look at the formula. For magnesium, Mg, there's only one because there's no subscript. And the same thing for sulfur, there's only one sulfur atom. Now this first oxygen atom we encounter has a subscript 4, so I know that there are 4 of them. For the hydrogen and oxygen of the water, okay, I have to use the coefficient to help me out now. So 7, coefficient 7 times the subscript 2 gives me 14 hydrogen atoms, and it also gives me 7 oxygen atoms, because 7 times the 1 oxygen there in the water. Now, for the atomic mass, we head to the periodic table. You would head to the periodic table to get the atomic mass. Magnesium has an atomic mass of 24, sulfur is 32, oxygen is 16, and again, I'm rounding these to a whole number. If you are actually looking at a periodic table, you might notice that there are some decimals with the atomic mass. I'm just rounding these to a whole number. Once again, hydrogen has an atomic mass and oxygen is 16. Now the mass subtotal. This is where we get the total mass for each element in the compound. okay? And we do that by multiplying the number of elements in the compound by the atomic mass. So 1 magnesium atom with an atomic mass of 24 gives me the subtotal 24. And the same is true for sulfur. There's only one of them. But there are 4 oxygen atoms. So 4 times 16 is going to give me that mass, that subtotal of 64. 14 hydrogen atoms, each of them with a mass of 1. That means the subtotal here is 14. And 7 times 16 is going to give me a mass of 112. Okay? Now this is the subtotal for each element. If I wanted to get the total mass, the formula mass, or the molar mass, but the total mass of the entire formula, everything in here, I would add all of this up. I'm going to add all of these items together, and when I add them together in my calculator, you can pause it here to add it yourself, but the mass is 246. Okay, 246. Now, the final column, calculating the percent, because this is all about percent composition, this is where you take your subtotal divided by the regular total, okay, total of the whole thing, times 100. Okay, and that's going to give you the percent. The percent of sulfur is going to be equal to the subtotal of sulfur, 32, divided by 246 times 100. Okay. Now in the next slide, I have these done out. You know, if you look very carefully, this is all the same information. But now if we go to our calculators, right? 24 divided by 246 times 100, that's going to give us, we'll say 9.8. And that's percent. All of these have the symbol percent afterwards. I'm not going to put that because I won't have a lot of space. But the percent of sulfur there is around, call this 13. It's not going to be exactly perfect. Just trying to be mindful of space. Let's see, we've got about 26% here for the oxygen. Now, for the hydrogen, I've got about, and again I'm rounding here, 6%, and about 46% here. So again, if you do that little bit of math to get the percent composition, you divide. You say, all right, subtotal divided by total times 100, and we've got it laid out here. And so that's how you get the percent composition. Now, what if we just want the percent of water? Okay, what if we just want the percent of water? Well, guess what? We're pretty much there. Now, to get the percent of water, hey, listen, just add up the mass of hydrogen and oxygen here, right? And we get 126. Listen, that 126 is the mass of just the water. It's the mass of my hydrogen and oxygen of the water alone. We're not counting the oxygen in the compound. We're just counting the water now. And I'm still going to divide it by the total. So I want to get the total mass of the water, which again, hopefully you're following. Remember from before, the hydrogen and oxygen at the bottom of this list were hydrogen and oxygen of the water, the 7 water molecules. Okay, so 126 divided by 246 times 100. That's going to give me the percent of water. In this case, there is 51% water in this compound. 51% water in the compound. Okay. So that is how you would do those calculations for the what are hydrates. I hope that helps out. But yeah, I'll see you guys in the next one.